Welcome to GeekFest, screencasts for developers. My name is Fani Renders and today is the first episode of the series. Today we're going to learn about schedulers in Windows Azure mobile services. Hope you enjoyed this one, guys. So schedulers in Windows Azure mobile services is exactly the same as the scheduled tasks you get in Windows. Difference being this is in the cloud. So what we'll do today is we'll build a small little scheduler that will poll Twitter every 15 minutes and populate a local database with tweets that contains hashtag something. This will allow us to have numerous clients that can pull tweets from our local store instead of Twitter. So let's get to it. Alright, so this is the mobile services section inside the Windows Azure portal. You can go to the portal by just pointing your browser to manage.windowsazure.com, and after you log in with your live account, you are able to actually start working in the portal. As you can see, there are already two mobile services I've pre-created for us, but let me quickly show you how easy it is to create a mobile service for those who are not aware on how to do it. So we basically click new on the bottom, and under the compute tab, mobile services, we simply click create. Now this will prompt us on a create as mobile service box. Here we need to specify a URL for our service. This can be basically anything that's not reserved .azure-mobile.net. So we'll go for tweet test.azure-mobile.net. So next we need to specify if we need to use a new database or existing database. In this case, I don't have any existing databases listed, so we'll just go for the create a free 20 meg SQL database they provide us. Clicking next, if we choose to create a new database, we need to say the database name and click create a new SQL server. Let's just call this login name Fani and specify a super secret password. And we simply click OK, or complete actually. This will go ahead and commission the mobile service for us in the background, and after a while it's finally done with its commissioning. So let's see what's inside there, shall we? So on top we can see there's a dashboard tab, data, API, scheduler, push, identity, configure, scale, and logs. Today we're going to focus on only the data tab and the scheduler tab. So to start somewhere, we need somewhere to keep our tweets that we will get from Twitter. This we will find under the data tab. We don't have any tables, so let's go and create one. You click add a table and we specify a table name called tweets. We will stick with the default permissions and click complete. This will now go and create the tweet tables for us. Once it's done, we have the tweets table there. There's absolutely no records in there. Next we go to the scheduler. Now this is the scheduled tasks I've been talking about earlier. Create one by clicking create a scheduled job. Let's call this fetch tweets and let it run every 15 minutes. We can actually set per hour, per day, or per month, but for now we'll just stick to the standard and click complete. So when it's done creating the scheduler, we can actually go inside there and investigate what's going on there. So currently it's disabled, as you can see. Last run was never, next run will be never. We haven't turned it on yet. But the thing I want to focus on today is this script section here. This is where all the nice juicy stuff will happen. So if we run this thing once, if we click run once, we will see the thing is starting the fetch tweets job. By default, it will write to the console log, you are running an empty schedule job, update the script for job fetch tweets. So it's done already, it's been started. So let's go back and see in the logs what happened there. And there we go. As we expected it will give us that message. So this is actually a simple introduction to scheduled tasks. Now let's get our tweet service going. Alright, so we are still in the fetch tweets scheduler in the script section where we left off a few minutes ago. Now we're going to start with our little script to fetch tweets from the Twitter API. Before we continue, we need a few variables. We'll grab the tweets table, and we'll get that from the tables.getTable tweets. Tweet is the table that we just created. We will also need the request object that we'll get from require, which will inject the request object in. And lastly, we'll assign a URL variable to the Twitter API, which is api.twitter.com/1.1/search/tweets.json. Do note that this has changed from the old version 1, which is now decommissioned. Okay, so one of the required query parameters we need to pass into the API or for the Twitter is the Q parameter, which is the query parameter. In this case, is anything that we want to search Twitter for. In this case, we want to search Twitter for, let's say, Azure. So any tweets containing the Azure tag, we want to actually pull out and stick into our table tweets, for instance. Okay, moving on, we need to have 4 more variables for security purposes. This came into the new version 1.1's security, where they actually where Twitter wants us to sign our requests. So we'll do this by creating one for consumer key. We'll just say that's nothing for now, and we'll call another one access token. And another one consumer secret. And the last one, access token secret. We can get these values from the Twitter docs when you sign into your account under dev.twitter.com. Under applications, if you create your when you're done with your application creation inside Twitter, it will give you the consumer key, secret, access token key, and your access token secret. So now I'm just going to copy and paste from the Twitter, from my applications page inside Twitter. These keys won't be available after this recording of the video, just for my security purposes. At the time of this recording, these keys are actually valid keys. Okay, so next what we're going to do is we want to create a function that can actually append the since ID to find the largest, most recent tweets that we have already stored, if any. So if there are no tweets that we stored, we can just grab whatever we get from Twitter at that time. Okay, so I've pre-created some code for us just to save some time. The next function is called append last tweet ID, that will accept a URL and callback parameters. In that case, we'll use the tweets table. We'll order the results by descending the Twitter ID column, and then we'll read it. As you can see on the success callback, we specify a function called read updates that will get the updates variable. Then we just merely check if the updates variable has a certain length, or has a length. If it has a length, then we just merely call the callback that we pass in with the URL that we passed in, and we just append the since ID query string specifying the first record, which is the Twitter ID, the very first one, which is actually the last one in our table. Else we just merely call the callback without the since ID. Okay, great. So let's move on. The fetch tweets function, we're gonna remove the console warn statement, and here I'm actually gonna add the predefined code that I've already pre-prepared for us, just to save us some time. But I'll go through the lines line by line. So in here, in the fetch tweets function, which is actually the entry point of our scheduler, we call the append last ID function we've created. passing in the URL variable that we've created earlier, and also a callback, which is the Twitter URL ready function we declare inline, passing in the URL inside there. Next, we then use the request object to do a HTTP get to the URL. And the next segment of the request is the OAuth segment. This is very important. By signing the requests ourselves is a hell of a job, but luckily out of the box, this actually supports the signing automatically. If we just give it the consumer key, consumer secret, the token, and the token key, and assign that to the OAuth object, it will do the signing for us out of the box. So on the success callbacks, we will call the tweets loaded function that will get back the error, if any, the response, and actually the body back. So then we just test if there's no error and the response is okay, which is 200 in HTTP terms. We then grab the results and use JSON parse to parse the body of those results coming back, and then we get the statuses part of the object. Yet again, refer back to the Twitter documentation over at dev.twitter.com if you aren't certain on how to use the 1.1 version of Twitter. So if there are any results that we can work with, we simply then use the console to log. We fetch some new tweets from Twitter, and then in our results table, or actually in our results object, or collection of tweets, we iterate through them using the for each statement, and then we just create a new update record that we just assign from the tweet that we get from the results, which is the Twitter ID, the text, the author, the date, and the photo, for instance. And then last thing to do is just take the tweets table dot insert, and we just push that update into the tweets table. If anything else goes wrong, then we merely just log it to the console as an error saying we could not contact Twitter. Okay, great, but before we carry on, we just need to go up to the URL. I forgot to mention we are not allowed to push a hash into our URL. We actually need to use a unicoded URL, a unicoded value, like hash is %23, which will say hashtag Azure. So when we're done, we click save, and it will save the script for our scheduler. And let's see if this works. So we click run once to invoke it again, and let's hope and pray it works this time. Great, so going back to our logs, we see that there is fetched from Twitter, so that's awesome. So we got some results we got back. Going back to the data section, we see there is 15 records available. Let's just see how that records look like. And glabamo, there's all the tweets containing hashtag Azure. So now what we can do is we can create a simple client that can pull those tweets from our local table. We can also read these tweets from our local table straight from the browser, but before we need to do that, we need to give it permissions to read. Otherwise, we need to specify the token for Azure in our request. Just to keep it simple, I'm just going to say read permission everyone, so that everyone can read this request. And then if we point to the browser, we go to tweet test.azure-mobile.net/tables/tweets. Hitting enter on that should give us results in our browser like expected. So our client apps can now query our endpoint like this, and it will get tweets from out of our API instead of Twitter. Alright guys, so that wraps up our first episode of GeekFest. Hope you guys enjoy it. Stay tuned for more later on. My name is Fani Renders. Go check out my Twitter page at Fani Renders or my blog at fanirenders.com. Cheers for now.